We've always dreamed of reaching for the stars, right? But the more we venture out there, the more we realize the biggest challenge isn't just the vastness of space. It's what happens to us, to our own bodies. Let's get into the incredible challenges that are hiding inside every astronaut. It really boils down to this. Every single part of us, from our bones to the way our blood flows, is perfectly designed for life right here on Earth. We're built for gravity, for our atmosphere, for this specific place. So you can imagine, the second we leave all that behind, our body is basically thrown into chaos, asking, what do I do now? So the first thing that hits you, and it's the one we all think is so cool, is floating. But what we call zero-G, or microgravity, it's way more than just a neat party trick. It's like the universe suddenly deletes the rulebook our bodies have been following forever. And the effects? They are immediate, and they are dramatic. Think about it like this. Gravity is a constant, full-body workout that you've been doing every second of your entire life without even noticing. Just standing up forces your muscles and bones to push back against it. So when you take that resistance away in space, your body's logic is simple. It thinks, oh, awesome. I guess I don't need all this heavy-duty muscle and bone anymore. And that leads to a classic use it or lose it problem. Without gravity, really important muscles, especially in your legs and back, just start to waste away. But what's even more worrying for those long trips to, say, Mars, is what happens to our bones. They can lose density at a rate of 1% to 2% per month. To put that in perspective, that's like experiencing a decade's worth of aging-related bone loss on Earth in just a single year in space. But it's not just your muscles and bones you have to worry about. Nope, the total lack of an up or down creates some other, sneakier dangers inside the body that can have some pretty serious consequences. See, here on Earth, gravity does us a favor and pulls all the fluids in our body downwards. In space, that pull is gone. So all that fluid just drifts upwards. It's why astronauts often have puffy faces and skinny legs. But it's not just about looks. You know that feeling when you hang upside down for too long? That constant pressure can build up behind the eyes and actually change their shape, affecting an astronaut's vision. And that is one sense you really can't afford to have go fuzzy up there. And then there's the danger you can't even see. Down here, we're tucked safely inside our planet's magnetic field and thick atmosphere. It's like a giant protective bubble. But once you leave that bubble, astronauts are exposed to way, way higher levels of space radiation. It's this constant, invisible hazard that's a huge long-term health risk. So after hearing all that, you might be thinking, wow, long-term spaceflight sounds kind of impossible. But, this is where we humans get clever. We can't change the environment of space, so we have to figure out ways to trick our bodies into thinking everything is okay and protecting them from the worst of it. This is the million-dollar question, isn't it? How in the world do you keep a person healthy in an environment that's actively trying to break their body down? Well, the solution is a mix of really hard work and being incredibly watchful. It really comes down to two crucial things. First, to fight that muscle and bone loss, astronauts have to work out like crazy. We're talking up to 2 hours every single day on special machines that create resistance. And second, their health is watched like a hawk. Everything from their eyesight to their bone density is constantly tracked to catch any problems the second they start. All this work isn't just about keeping a handful of astronauts safe on the space station. Solving these incredibly complex puzzles about our own biology is the absolute key to humanity's future beyond Earth. Seriously, this research is so important. If we ever hope to go on long trips to Mars, or maybe even build colonies on the moon, we have to master the science of keeping our bodies from falling apart in these alien places. When you get right down to it, all of our amazing cosmic dreams are tied directly to our biology. And that quote really just says it all, doesn't it? Figuring this out isn't just some interesting science experiment. It's the essential foundation we have to build if we're ever going to have a real, lasting future out there among the stars. So, as we look out at the red plains of Mars and the moons of Jupiter, the big question is still there. We can build the rockets, we can design the habitats, but can we prepare our own bodies, which were made for Earth, for that journey? Answering that might just be the greatest exploration of them all.